That was a good segue into discussion about oracles, and now we're going to get a little bit more finely detailed with 6 people that are in the business, working on different approaches to oracles, and talk about why they're so important, specifically to decentralized insurance. So I'd like to welcome Jack Peterson of Augur to the stage, Thomas Bertani of Oraclize, Doug von Kohorn of Rhombus, Sergey Nazarov from Chainlink, and Julian Bouteloup from Flying Carpet. Appreciate everybody being here, and thanks to EtherRisk, it's a great forum here. So my goal for the conference today is basically to introduce or allow each of the panelists to introduce themselves and then really get out of the way. So expose you to a few different approaches to the Oracle problem and how it relates to decentralized insurance, and hopefully sponsor some debate and differences of opinion, and then solicit some questions and answers from the audience, which in my opinion is always the most interesting part of these conferences. So how about a minute introduction from each of you, and maybe just a mission statement about your project. So Jack, kick it off.
Thanks, Ron. I'm Jack Peterson. I'm co-founder of Augur. Augur is a decentralized prediction market platform built on Ethereum, and one of the important parts of prediction market is being able to resolve the markets after the fact. So once a market has been run, you have to have a way of saying what was the actual outcome to this. But people like to use prediction markets for politics. So an example is a market on who's going to win the, say, presidential election. And so the Oracle would say, after the presidential election has been run, who actually won? And the way that Augur implements this is by using stakeholders in Augur itself. These are people who hold Augur's native token called reputation. These people are incentivized to report what actually happened accurately, because it's the easiest and cheapest and most profitable option for them to do.
Good. You can.
Hello to everyone. I'm Thomas Bertani, CEO of Oraclize. Oraclize has been operating on the Ethereum mainnet for 3 years, and it's an Oracle service which so far has processed just on the mainnet approximately 800,000 requests, and it's currently serving a few hundreds of contracts on the Ethereum mainnet. So our objectives are the ones of enabling any data source on the internet, so any API service, to interact with the blockchain without needing to adapt to the blockchain itself. And on the other hand, we try to give strong guarantees on the fact that the data we deliver to the blockchain is indeed authentic and it has not been tampered with by us. So you can verify, thanks to some trusted computing based proofs, that the data we are sending to the blockchain is authentic. And yeah, this is at the core of our value proposition. There are several problems in the Oracle space, and we think the one we are solving now is one of the most complex and most important. There are a few others that you will see also with the other projects. So I hope that in the future we see more cooperations among the different Oracle services, so that we can provide, an actual Oracle which solves the entire problem and not just, yet another Oracle-specific problem, which is maybe something just a specific implementation has.
I am Doug, the CEO of Rhombus, and we're an Oracle platform that's trying to curate both sides of the market, so best-in-class data feeds from high-quality, consistent, reliable data providers, and we're trying to deliver that to customers in a clean, computable manner. So we package that along with a very capable computational platform, and it has AI, machine learning, image recognition, all the things you come to expect from a computational platform. We aggregate this data together and we provide it to a custom business need. We've been on mainnet for a while, and we hope to work with these other Oracle providers as well.
Hi everyone. I'm involved in putting together a project called Chainlink. Chainlink is an open source standard for how oracles work in multiple contexts. So the insurance context, it usually has to do with the IoT data, and so it's important that there's an open source piece of software that can portably live in different types of devices, not a closed source piece of software that runs on its own platform, right? So you want a piece of software that'll go wherever your data is and provide that data to your contract. So that's one fundamental tenet of what we do at Chainlink is an open source piece of software that's portable across whatever environments you need to get the data from. The second piece of our thesis is decentralization. So whenever possible and whenever economical, if you ascribe to the decentralization thesis, why we essentially believe smart contracts are reliable at all, then you would theoretically have a budget for buying decentralization and reliability on the level of your inputs that trigger your contract as well, right? So if you're going to pay for decentralization of the contract, you're probably going to be willing to pay for decentralization of the trigger/input, which is the second dimension of what we do, is we create an open source piece of software, a standard really for oracles to function in a decentralized manner. And the third piece is on top of that, we layer on a trusted execution environment and multiple trusted execution environments like Intel SGX and others, which there's not enough time to go into in this minute. But those three fundamental tenets are the gist of our approach.
Yeah, sorry, I lost my voice last night during the party on the pirate boat. So I'm the CEO of Flying Carpet. Flying Carpet is a decentralized protocol layer for oracles, and we focus on proof of observation from satellite images. So what we do, we organize computational data scientists where they all incentivize to stake to build the best model for a specific use case, and then we tokenize this model for anyone to invest. So we give opportunity for anyone to actually invest in this model for short-term or long-term revenue. So for example, we focus on building 5 different use cases at the moment internally. We're building a cacao model that can predict the production of cacao in some place in South America. And we can actually, people can invest in this model. We're building a carbon offset, so we can actually calculate the density of a forest and turning proof of observation for this density of this forest, so we can actually do carbon tax incentivization. We're building a cross. So regarding insurance, we're building a model that can calculate a parametric insurance from space, looking at farming, for example, land of crops, and we calculated this crop where it was damaged by a hurricane or catastrophe or by flooding and all this stuff. So we really focused on building this model and turning them into a non-fungible token asset where everyone can invest in this model.
Okay, I already introduced Witnet, so I'm okay with passing so that the conversation can go.
Sorry about that. So we'll keep passing around this mic, but one of the questions that I wanted to ask the panel, there's different approaches to the Oracle problem. The question in my mind is if one is good, is more than one better? And wondering about your approaches or thoughts about combining oracles to get even a better, more reliable, more durable piece of information that can go on the blockchain. Oracles sometimes get the data wrong, or the messenger gets the data wrong. So just some thoughts about how the combination of oracles may be more or less effective, and what keeps you up at night about the quality of your oracle? Like, what can go wrong?
It's a good question. So Augur is, on Augur, when someone, so all markets in Augur are user created. And the person who creates the market specifies what the source of the information will be to resolve the market. When we say there's a single oracle, that Augur is an oracle, really it's Augur's users acting as an oracle, and they pull information from whatever source that the person who created the market specifies. So in that respect, I think that Augur actually, melts quite naturally with other oracle providers in the sense that someone creating a market could specify, for example, Oraclize would be could be the resolution source for a market, in that case, Oraclize would just be used to look up the actual result when the market resolved. So I think that's a fairly natural combination.
So as for Oraclize, we try not to say anything on the quality of the data on purpose. So the idea is that Oraclize just gives you the wiring and the guarantees you need from a technical perspective to verify that the data comes from the third-party data source that you have chosen, that you want to trust. So the idea is that if I were asking you here, what's the temperature in Prague, the reality is that even if you were aggregating the data, I bet that 80% of you would look at the first same result on Google or something like that. So it's really complex, because the reality is that the data sources which are reliable indeed are not necessarily something objective that everyone would agree on. So it's really complex, and in general what the Oraclize approach is trying to give a general and very abstract and general purpose way to basically reach out to any data source you want and leave the aggregation part to the final user on the blockchain. So the reality is that even now some of the Oraclize-based contracts are using Oraclize to get data from different data sources and then they aggregate it on the blockchain. So this is quite expensive, but it already shows an approach where different oracles, such as the ones we have here, could be potentially used in the same contract, and then the result may be aggregated on the blockchain. So the reason why we don't do the aggregation on our side is that we would be making some assumptions on how the aggregation should work, which is really dangerous, equally dangerous than having the data source being compromised. So the reality is that even the aggregation itself looks simple, but it can be quite complex, and we believe it can be different from one use case to the other. So we leave that to the user, and I think it would be very natural to have some third parties like our clients or people in the community that come together and use more than one oracle and aggregate the data from the different oracles in that contract.
Yeah, this is a great question. I think the way Rhombus deals with this is we do two things. One is we try to find the best data sources for a given signal that the customer is looking for. So in the case of weather, there's a lot of amateurs that put sensors out around the world and they report that data. There's also professional weather services. And then another thing that we like to support for our customers is clarity and judgment. So we're okay with whatever business context the customer actually develops for how they interpret temperature, for example, as long as it's a transparent computation that you can prove to anybody. So that judgment is recorded, and when it's run consistently with the reliable data. And so that's kind of how we look at that problem.
I think part of the question was the types of oracles, is that right?
There are differences in the types of oracles represented here, and my question was your approach and whether it would benefit from multiple oracles.
Oh, I see. Okay.
The question.
Yeah, so generally speaking, we take a more decentralized, we give people the choice to buy more security by purchasing more independent node operators. So it's not necessarily our place to tell people you need 1 or 2 or 3 or 5 or 10 nodes. It's our place to provide a system that allows people to purchase the decentralization and the reliable verification of an input to the degree that they want to pay for that, right? So if right now decentralization on the smart contract level is paid for as a premium good because nobody can tell you how much decentralization gives you how much security, right? The approach of our system is basically that we're making a system where if you wanted to purchase 5, 10, 15, 20, 50, 100 top tier nodes to verify the quality of an input, and either experience or the academic world or whatever combination of proof gave you the idea that buying more decentralization gets you a more reliable input, then you should have the ability to buy the decentralization to guarantee the quality of the input that you want, that you're willing to pay for, right? So the fundamental issue we see and the way we see people using our system currently is in the places where security actually matters, people will tend to spend on decentralization as a thesis that buys them more security, or at least buys them certain guarantees that they can present to their users about security, right?
Have you noticed a difference in the quality of the data between a purchase of 10 nodes versus 100 nodes?
So the quality of data is a different question. So there's the origin of the data, then there's the middleware node operator. Sometimes they can be the same entity. Initially now in the early stages of our space, it's usually separate entities, right? So you can have 5 independent node operators verify one data provider, 5 more verify another, 5 more verify another. You could have 5 verify one to trigger the contract and 5 more act as a fallback, where it's just like an additional, error checking scenario, or whatever configuration of reliability you want. So the quality of middleware won't solve the quality of data being provided to you. What the quality of middleware will do is it'll provide guarantees that the data reaches your contract in a way that is reliable. Because right now, the attack vector, it doesn't seem to be the smart contract networks with thousands of nodes. It doesn't seem to be the data providers that already have a data business and have hardened infrastructure, the better ones. It seems to be the middleware that has come into existence over the past year or two and is very new, right? That's the attack vector. So within the logic of our space, the thesis is decentralization. That's the thesis. And then on top of that thesis, you can layer on other things. You can layer on trusted execution. You can layer on many other pieces to provide additional guarantees. That's the gist of the approach.
So in our Flying Carpet network, we focus on satellite images. So it's kind of, for us, it's very unlikely that someone will be able to tamper satellite image. We partner with the 3 biggest satellite images partners around space. So if we got image that looks a bit suspicious, we can always fetch data from other satellite provider. So that's how we make sure that the information coming into the model that we trained for a specific use case. For example, we're doing rooftop anomalies in Mexico Beach of the United States. So we can actually just fetch every 30 minutes the data from the satellite. But also what we do, we got this pricing mechanism where we can actually, if the data is too expensive in one or not available in one satellite, because for example it's every 30 minutes or whatsoever, and there was a bit of shadows, and we can actually switch between those two data providers. And also we're building on a testnet something called Alpha, the Flying Carpet network, that if the data is not available on those providers, satellite providers, because it's too expensive or not available, we actually post a bounty, like a phone mechanism, which you've got this TCR mechanism of bounties. So we incentivize someone that live in nearby this specific this client place, for example, the farm, that has a drone, go there and can collect the data. But this is really doesn't represent much in the business model. We really get all the information we require from satellite images. That's what we focus at the moment.
I pretty much agree with Sergey's thesis on this. And in Witnet, what we allow smart contract developers is to choose as many sources they want. They need to specify them. They need to specify how data will be retrieved from them, how it will be normalized, how it will be aggregated. For example, if you want the average, that first you need to remove the outliers just in case something went wrong. And also to choose how many nodes will be doing this retrieval, aggregation, and delivery work. So it's actually up to the smart contract developers to understand what are their needs, what are their trade-offs, and whether they need more decentralization or they need more cost effectiveness or later latency or whatever they need.
So let's go in reverse order. The question that I'd like to ask is, what happens when the traditional data providers start to come into the space at the end? Like many of the Oracle solutions rely on traditional data providers, but not as the end product, more as a validation of the end product. What happens when Reuters or Bloomberg or the satellites become their own endpoint for the information themselves? How do decentralized solutions compete with the incumbents?
That's interesting. Generally speaking, I think for smart contracts consuming public data sources, it's again up to the smart contract developers to choose sources whose public reputation is much more valuable than the value handled by the contracts, because otherwise they would be creating a really interesting bounty for people to try to attack the source in order to tamper with the contract.
But if they knew that, then they wouldn't need to be a decentralized solution.
Yeah, it doesn't change anything.
Right, okay.
Yeah, so in Flying Carpet, we actually seen this happening. Those big satellite organizations are starting to use the data to build their own model and use those models to sell the information to Bloomberg or Thomson Reuters and hedge fund and all this stuff. The main problem is scaling. So what we saw in this decentralization we basically incentivize people to really quickly build a model by tapping into the existing market of data scientists, for example, coming from Chicago. And they can actually build this model really quickly, but a satellite company, they cannot. They have to hire more data scientists in order to build this model. And also, what we do is, for example, a data scientist for example, in Chicago, or like those big organizations, there was Airbus, they have satellite, they actually post a competition on Chicago to build a specific model, so a specific oracle, to do a specific output, like data insight. They pay a competition of data scientists about like $60,000 US. And the first prize is $25,000 US for the data scientist. The data scientist will probably spend about between 3 and 6 months to work on the specific creation of this model. $25,000 US, you might think it's a lot of money. But for data scientists that would earn normally $150,000 US, $200K a year, working for 6 months and getting $25,000 US is pretty much nothing. So what we do in our decentralization of this creation of this model, we give the exact same amount of money for the data scientists to build this model, but we also give a percentage stake in the model. So then the incentivization is not one shot. It's not like I will get this price as a bounty or get the $25,000 US to build a specific model to extract, for example, parametric insurance for the specific farming or whatsoever. You also get short-term and long-term revenue of this future model that will be used.
The stream.
Exactly, the stream. So then everyone is incentivized. And what we do, we not only do a building oracle, we turn those non-fungible assets with a specific model into, we apply different kind of financial instruments on the top of it. So we can actually transform the model into, we can like apply interest rate on the top of models. We put this model into a DAO, and this DAO can be, for example, specialized in climate change. And the climate change will hold all the models that actually do specifically for climate change. So calculating the melting of the ice in Antarctica, or like trying to fetch the pollution on the beach somewhere. That's what we do, and then we give people access to this asset, this financial asset, like a financial stock market asset, but we turn this model into a financial product that people can invest in. And we trigger all financial instruments on top of it. So you got way more incentive to actually build a model for Flying Carpet than actually using provider. And so now we got people from provider asking us to build a model, and those providers, they want to invest in the model.
You're making them partners.
Exactly. So instead of having one-to-one as a client and selling the data, you sell across thousands of people.
Yeah, Ron, I think it's a very valid question that you pose. I think there's two kind of key nuances here. So we've been talking with large top-tier data providers, the origin, like the exchanges and other places that even generate the equity data, and IoT level people and stuff like that. And then there's the aggregators. And both of those groups are very bottom line focused groups. So there's going to be some time until there's enough volume in the smart contract ecosystem to justify them making an investment and figuring out how to properly put data on chain for use by contracts. Now that's not to say that the data providers that move sooner don't stand to benefit greatly. They do, because the contracts that are built first and succeed first will probably be built using their data feeds, right? So it's kind of a chicken and egg problem in that we need good data providers or good methods of acquiring data into contracts to build the contracts that data providers see as a sign of market dynamics, which would justify their investment in providing data to contracts. So it's a really weird circle of events here. One way to short-circuit this circle of events is you create an open source, highly reliable Oracle framework, something like what we've made, and we allow other people to resell their data. So reselling data within the kind of data world is very common, and so our initial approach to solving this very fundamental chicken neck problem was providing software and incentives for people to be able to resell other people's data as basically a node operator. So that somebody can go and say, I think this data is very valuable, and there's like 3 or 4 node operators that will sell that data, and now you can get that data from 3 or 4 node operators, but it's still from a high quality source. The second nuance is that I think that the terminal scenario is that everything's going to end up here once there's sufficient volume and data providers, either the early adopters or the people in the middle or the laggards or whoever, once they all wake up to the kind of monetary potential of providing data to contracts, they're all going to jump in and say, this is the place I want to sell my data. And them signing at the origin is fundamentally more secure. So at the end of the day, it makes more sense. So I think it's very likely this is where we'll end up, which from our perspective, that's part of the reason we're making an open source, framework, highly security reviewed piece of software that any data provider can use to sell their data directly to contracts. Right, so we have this software right now. We already have data providers selling directly from their infrastructure to contracts. The issue is the volume isn't there for more of them to do it. That's the issue, right? The issue is where's the volume to justify their investment in this approach? And then the question is, okay, what software do I do this with if I do want to sell my data to contracts? At which point our plan is that they kind of use Chainlink, because that's what we're building, for that terminal scenario. Yeah, I think that answers most of, yeah, okay.
Yeah, this is a good question again. It's why Rhombus is focusing on computational judgment. We want to make a piece of judgment or a model something that anybody is encouraged to develop, and then they can extract rent from that model depending on how sophisticated or useful it is. So anybody can come onto our platform, build some judgment about the weather status in Boston, Massachusetts, and they can start selling that or some model on top of satellite data from our satellite providers. We're hoping to incent this ecosystem of people who have domain expertise and can start extracting rent from people who want that domain expertise at scale.
I think at Oraclize, we came to a slightly different conclusion, but our reasoning is very similar to the one that Sergey has just explained. So when we started in 2014, we started looking around at, like all the resources around oracles. And the reality is that back then, everyone was assuming that the data sources, like the data providers, had to be the ones integrating with the blockchain. This was the initial assumption. And this was actually the definition of an oracle back then on the only resource which was available, which pretty much was like the bitcoin.it wiki page explaining an oracle, which is still out there. So if you check it, you will see that this is the definition of an oracle, like Bloomberg integrating. The reality in the real world is that if you go speaking with those parties, At the moment, most of their interest with blockchain comes from the opportunity to do a very good press release, but they don't see enough traction yet to integrate and to take action. So something as simple as a digital signature, which conceptually has been around for 40 years approximately, still is being really complex to integrate into HTTP itself. So there is no consensus on how the HTTP API providers should sign their data. Why? Because everyone is using HTTPS and via TLS, and everyone is quite happy with current status of things. However, this makes it really complex to reliably connect those data that are available on the internet and delivering them to the blockchain. So how do we do that? This is very complex, and this is why few approaches here on stage are using trusted computing techniques to prove that that connection was safe. If data sources were to sign the data, this would be very trivial. It would just mean verifying a signature on the blockchain. The reason why we don't believe that data sources should install a middleware on their side right now is that we don't really know if the Ethereum mainnet will be the winning chain. Of course, most of the community here may say, okay, it's definitely going to be that. The reality of things is that if you look at the ecosystem in general, there are many different approaches, and there is not a single reason why the data sources should bet on Ethereum only, or on Rootstock only, on Bitcoin only, on EOS only, on Fabric only, and so on. And the reality is that if we look around, the only integrations which are really out there are pretty much being done on permission chains, like on R3 Corda, on Etherledger, and things like that. So what we are proposing right now is that basically, since we don't have high expectations in the short term for what they may do or not do, we just suggest that they should start signing the data. So if they sign the data, then they can leverage our existing infrastructure, and they can automatically gain access to any blockchain. Like right now, Oraclize is integrated literally with most of the blockchains out there, like Fabric, Corda, EOS, Ethereum, Testnet, Mainnet, and the data sources don't really care about the alt forks. They don't care about the community opinions on the block size, really. They just care about selling the data. So this is why we think that their action should be minimal, and that signing the data is already good enough to deliver in a reliable way their data on any existing platform.
So Augur integrates pretty naturally with pretty much any data source because the data source that's used to resolve Augur markets is just specified by the market creator. So in that respect, I don't see Augur as being in competition with data providers. Like if data providers want to provide a signed, trusted source of information about anything, if it's Reuters or Bloomberg or whoever, I think that would be great. People could use that as the resolution source for Augur markets.
So one quick question, hopefully a 10 or 15 second answer, and then we'll open it up to the audience. Don't be a hater, because I think it's important for us to start thinking about how these businesses make money, especially when volume and scale is so low. So 15 seconds on what your project business model is. Keep it tight so we can answer some questions.
Well, Augur doesn't have a business model per se. We're a nonprofit software development foundation, and we're just developing free and open source software. So it's a free open source prediction market platform. Anyone wants to chip in, they'd be more than welcome to. So Oraclize is right now is not able to give you the guarantees that it will keep operating forever. So what we do guarantee today is that if we answer, then the answer is authentic, and you can verify yourself. So in the worst case, you will not get any answer, basically. So this is why there is a small fee that you are sending to Oraclize as a way to incentivize it to answer. In most of the other approaches,
you do have some ways to either like punish members that are not behaving correctly, that get rewarded somehow, or you are rewarding them actively. So here is like if Oraclize was one of those actors which gives you strong guarantees on the authenticity and needs, like small fee to be paid up front in order to have a good like reason to answer.
We charge a little bit on top of what it costs to pay for the data and deliver the data onto the chain. So, and if the user has developed a computational judgment or some sort of model of the world that they want to sell, then they can specify a price as well.
We make open source software, and we think we make it so well that it's likely to become a standard. So that's our approach.
Yeah, so we're not involved in that data provider. We just we build this model to make proof of observation for the real world from satellite images. So that's what we charge for specific proof that something happened. For example, if you do parametric insurance for Ether risk, and you need to prove that something happened for the crops, we give a binary answer. Is this correct or not? What is the level of damages? Between 1 and 5. What is the quantity of that specific production? What is the state of this rooftop? How many anomalies? How many holes? What is the biomass spectral camera biomass analysis of the specific? That's it. Thanks. So we make money.
Witnet Foundation's only mission is to develop the protocol, to foster the ecosystem, to develop the first implementation of the Witnet full node, and then we will just relinquish power to the open community.
So, are there any questions from the audience?
How do you handle exceptions? Or to be more precise, when a question itself is not narrowly defined to get to an answer. For example, we had an earthquake in New Zealand, the car park was locked down, the car was locked in there for 2 years, how this is worthless. If you ask anyone, is this car in good shape and operational, it will say yes, but actually it's completely broken after less than a year. So what are your approaches to that?
So that's correct, and the model we're building, they cannot be 100%, so it's based on the logless. So what you do is based on a mass. So, for example, insurance, you give a prediction that something happened on a huge numbers. So you can have a percentage of error. So you might actually send the claim to someone which was probably a little bit wrong, but the oracle is probably right to 98%, for example, because it's a model. But if you, for example, if it's very likely that you don't believe this model can actually trigger a signaling, and you will basically manually check yourself that something happened.
Rhombus is working with different arbitrators, so depending on your business context, you can kick out your decision to different arbitration options. So we do it.
So when you use Oraclize proves that the data is authentic as it was reported by the data source. But you are always trusting the data source. That's why we don't make assumptions, we don't tell you what is the best data source according to us, but we leave this decision to the developers. So developers may use more than one, and when you use a data source, they will make their own assumptions. So if you go on Google and you ask what's the temperature in Prague, they will make assumptions on the number of decimals you want, on the unit you want, on the exact location, and things like that. So the reality is that if you don't trust the assumption of a data source, it means you are not trusting the data source itself. And in the first place, your query doesn't make sense in the blockchain context. So the best you can do, of course, is using more than one and trusting the individual assumption of each one of those.
While all Augur markets have the possibility of resolving as invalid, and that is the expected result if a market is badly worded or about something subjective. And in the event that a user disagrees with the tested outcome of a market, any reputation holder has the opportunity to dispute the outcome by posting a bond in reputation.
Yeah, what Thomas and Jack both said makes a lot of sense. Basically, to Thomas's point, if you're going to write a contract around the data source, make sure the data source is going to reliably give you the input you want for your contract to function correctly. Now, if your data source can't give you that, and you can get the data from multiple data sources and aggregate it somehow, then using multiple oracles might be useful for that. So you arrive at an index or an average across data sources, kind of piecing the pieces together across data providers. That might provide some assurance. Realistically, there's situations where there is no structured data to resolve the contract. In those scenarios, Jack's system works quite well, where you have basically people vote on unstructured data events. So kind of like, how do we all feel in the room right now, right? If 90% of the people in the room feel good, then great, then we resolve the market and that's it. We're not going to get a data feed to tell us that, right? So it's not as much a problem of the Oracle as defining what's triggering your contract and whether the place that's triggering it can even be structured data at all. And if it can't, then you're probably better off having some kind of voting scheme or something similar to what Jack is working on.
Do we have time for one more question? Is there any other questions from the audience?
Sergey, and you say open source and Oraclize incentives. Would there be any opportunities that maybe you two can work on something that's fully standard and with proper properties? You two cooperation on something that's really, something better for the cause.
Sorry, I don't understand the question.
As in, you are working towards something that's open source. Yeah.
This sounds more like a suggestion. What is the question?
Okay. Would you two maybe work on a service that is of proper quality? Let me say, operate among yourself instead of creating competition. If one of you is working on something is able to achieve a standard.
Okay, I think I have an idea what the question is. I think it has to do with collaboration. I think there's a lot of space for productive collaboration in the Oracle part of the decentralized stack. And like a lot of the people that I meet solving the Oracle problem, they all want to see kind of the world change in the same direction. So.
Maybe I can. So, as I implied at the beginning with the first question, I think the Oracle space has different kind of Oracle approaches, but also many problems to solve. And I think that some of the projects here has been trying to solve some of those problems, and some other oracles have been trying to solve another side of it. So, for example, Oraclize has been focusing a lot on using different trusted computing environments. But not much in providing guarantees of availability in the long run. While, as you suggest, projects like Chainlink or Witnet and Augur, of course, have been pushing a lot for like some incentive mechanisms that guarantee that an answer will be given. So, yeah, I mean, as I also implied in the second answer, I think there is a lot of space for collaborations, and definitely I think what the ecosystem needs is like a unique way for smart contracts to get external data, so that they don't need to understand and see all the complexity behind the Oracle system. They can just audit something that makes sense, understand the trust implications, and then get the data from there.
So we're out of time. Thank you all to the panelists for 6 different approaches. And thanks to the audience for coming today and participating, and appreciate it. Thanks very much. Thank you.